Hello, good morning, everyone. Steve Cruin here with Midland Technologies. Today, it looks like we've got a few more attendees that we're waiting on here, so we're just going to give it a couple more minutes, and then we will get the presentation underway. Thanks much, and we'll get after it soon here. Alrighty, good morning, everyone, and welcome. And thank you for attending today. My name is Steve Cruin, and I am the National Sales Manager at Midland Technologies, based here in Minneapolis-St. Paul metro area. We are really happy to be able to present this series of webinars here that Midland has developed. These webinars are focused on high-pressure die casting industry. Midland, along with its sister companies, are all part of Innovance, a 100% employee-owned organization. As owners, we are all dedicated to providing their customers with the highest level of quality products and customer services. I would like to introduce the presenters for this webinar. We have Larry Winkler, who is president and owner of Owentech, Inc., Die Casting Consulting. In 1996, Larry developed and implemented vacuum assistance in chill blocks and die casting, and a year later, working with Midland Technologies, he commercialized the product. Larry has over 35 years in the die casting industry at 5 different die casting companies in a variety of engineering roles. We also have Bill Zabracki. He is our product engineer here at Midland Technologies, where he designs and coordinates all engineering activities. He has 30 plus years in the manufacturing industry, ranging from electromechanical circuit board test units, hydrostatic high pressure valves and pump systems, and now high pressure die casting components with an emphasis in designing, managing, operations, and quality control. If anyone has any questions, please submit your questions via the chat feature. Thank you again, and I will now hand it over to Larry and Bill to begin the presentation. Thanks.
All right. Good morning, everyone. Thank you again for joining our webinar. This is Bill Zabracki of Midland Technologies, and we also have Larry Winkler on the phone.
Good morning, everyone.
And so today we're going to be talking about troubleshooting evacuation methods in high pressure die casting. So part of our discussion today will be identifying problems associated with poor evacuation and determining the cause of the problem and outlining solutions for each issue. And at the end of the webinar, we'll be answering questions. And if you have questions regarding vacuum or evacuation of any sort, or any other questions, the general questions with die casting, we'll be happy to answer those as well. So our first thing, look at what defects are related to the lack of adequate evacuation. And of course, the first part is surface defects. and cold flow, cold lap, chill, non-fill, and swirls. Larry, can you kind of go over a little bit more description on that?
Sure. These defects can also be they're related to evacuation of the cavity. They can also be influenced by the amount of time it takes to fill the cavity. In other words, the cavity fill time, and also the temperatures involving metal and or the temperature of the tool itself when the metal enters it.
Excellent. And then we also have gas porosity, which is very common. And that's where we all know this too, that the gas is trapped in the metal flow during when the cavity is being filled. And blisters can also be developed. And of course, blisters are gases that's trapped under the surface of the casting. And then we also have outgassing. And defect surface finish occurs when bubbles appear during painting, plating, or other finishing processes. And there's stain casting, which is a discolor of the casting, and edge porosity, which is the coarse porosity at the gate. And Larry, do you have to kind of fill in the kind of more details of these types of things?
Sure. Outgassing, of course, if you're in die casting, you're finishing parts. If you finish parts, you're familiar with that condition. Of course, it's internal porosity and trapped in the casting at the time of solidification, and this porosity is generally closer to the surface of the casting, although the entire casting outgasses the life of the product. Die casting just doesn't stop outgassing. It continues to outgas if you don't use some means of either minimizing that gas after or during your injection of the metal, or it can be also addressed at a later time. And I've had this experience many times with casting, where you would heat the casting up, and the outgassing would occur on the surface of the casting, ruining either paint or plating. One way that can be addressed is to post-heat the casting to precipitate the outgassing of the part prior to finishing. There are certain temperatures and length of time associated with the various alloys to facilitate that outgassing. And by evacuating the cavity properly, of course, we can minimize that condition by either using adequate venting or vacuum. Stained castings, of course, are discolorations that occur from the actual contact of the metal with the with constituents in the cavity itself, such as primarily spray, or can also be caused by the lubricants in the shot sleeve. And when the metal comes in contact, of course, it creates a carbon, and that's what creates the discoloration. Generally, you can't get that out of a casting unless you use a vacuum to remove it. There are other ways of minimizing the amount of spray and so forth that you address that problem too. Edge porosity is just says it's gas trapped at the point of the gate. It can occur around the periphery of the casting in different locations, but it's mostly associated with temperatures and or the cavity fill time. So and again, we can minimize that by having proper evacuation. And that's about
Excellent.
it.
Good. Okay, so the first one we want to discuss is insufficient evacuation, and there's a number of possible causes here. The first one we have is the improper size calculation of evacuation area. And this could be either whether you're just venting or using a vacuum assist as well. And Larry, if you can kind of go over the solution for this cause.
Sure. The solution in this case, and we use this, we have some proprietary software that calculates the area required to evacuate the cavity. And the attributes we use in those calculations are associated with the casting itself and the machine parameters. And by performing these calculations, we use PQ square. We arrive at a cavity fill time. We arrive at area is required to evacuate the cavity in a certain amount of time. So it's important that some type of calculation be arrived at, and then some kind. If you'd hope you would come up with some quantitative method of collecting the data to assure yourself that what you've arrived at is adequate and going to do the jobs. We've developed that over the years in applying this technology, vacuum technology assistance, over the years in die casters.
Right. And that kind of leads on to the next cause too, the improper evacuation method selected, whether it's conventional venting or valveless vacuum blocks and such. And part of these parameters will also are based on what type of venting you are using.
Yep, they relate really. The first thing I do when I look at a casting is what does the customer require? What's the application of that casting? Is it thin wall and appearance a critical issue, or is it a casting that's going to be subject and required some strength requirements that meet customer requirements, or do we have to have a pressure tight casting? So each of those, and if you've been dealing with die castings for any period of time, you realize that each of these applications have a great effect on what you can use and get by with using conventional venting, a chill block, or some type of the valveless vacuum blocks to evacuate the cavity.
Right.
So application though, and that is the big key factor here. And what do you select?
And Larry, maybe you can talk a little bit about too that if you have an evacuation area that you determine, and but what if you have too large of an evacuation area? What issues can involve?
Right, that's pretty common. Back in the day, and I think it probably occurs today to some degree too. We used to call it cracking the die or venting the die or letting the die breathe. What tends to happen, of course, is if you have excessive amount of area to evacuate, you end up evacuating the cavity fine, but the problem is that the metal never sees the proper pressures required to pack the metal out at the end of shot. Subsequently, you've got a casting that appears real nice on the exterior, but is full of pores on the interior because you haven't done that. So if you can oversize, evacuation by doing this, and so it's establishing that proper size and proper design, and selecting the proper application. I always say if there's a question of whether or not vacuum would be required, or you have an idea that would be required, is to install vacuum blocks. You don't have to necessarily run vacuum. If you find at a later time that it's not necessary, you can use a vacuum block as a vent block also. So I've done that, a number of times. I've also run quantitative tests on trying to arrive at these conclusions between vacuum and venting in various applications with various die casters. And I've not come to a quantitative answer that I could put down mathematically on what castings would require a vacuum, or what type of tool would require venting. We only know that it's certainly assessed in the producing quality casting.
Excellent. And then another possible cause for insufficient evacuation is the design of the evacuation system with the system outlets and runners. And what we do here what we suggest here at Midland is to and what everybody knows is to locate the outlets at the last places to fill on the casting, and then of course size the outlets and runners properly. And Larry, if you can that a little bit as well.
Yeah, this is one of my I guess my pet peeves here is the fact that when we do see issues with vacuum, let's say not performing properly, a lot of those cases involve inadequate design of the vacuum system, and I call that the vacuum system internal to the die, and being properly located in either the primarily and a must-have as the last place to fill in the casting is ideal. Also, the design of those outlets and the runners, and having enough turns. We specify as a rule 5 turns at 90-degree angles as a minimum to help reduce the velocity of the metal, because we're primarily interested here with the velocity of the gas being removed, not the velocity of the metal. As a matter of fact, if we could reduce the metal or metal never reaches the block, that would be an ideal situation. But we see a lot of times our designs that are not adequate. They may prematurely, because of their design, actually block the vacuum from another portion of the casting to being functioning properly, and subsequently can trap gas in the part, and or just making it non-functional. So that's about as much as we can say on that one, other than going through some designs. We do provide those design with the purchase of a block. We do design these runners and outlets for customers.
Right. Yeah, that's something we do provide here at Midland. Okay, we'll go on to the next slide here. We have a few more possible causes of inadequate evacuation, and misalignment of vacuum or vent blocks, and of course this will can restrict the flow of the gas as it comes out. And Larry, if you can kind of go over that a little bit more deep.
Yes, there are some pretty straightforward and simple ways to determine this. One we've come up with, I know a lot of people probably have used it, it's just using silver solder, lead solder, taking a strip of it and putting it in the block itself, and then closing the die up. That right away will show you the pattern and potential areas that you do have misalignment. It's that thickness, of course, indicates the gap that you got in the block, and of course that gap's necessary for the gas to be evacuated. So obviously, if there is that problem, you could go into the tool and make adjustments to the alignment. That's one of the reasons we have built keys in these blocks to assure proper alignment, whether they're drill blocks or they're a vacuum block. One thing I'll note regarding this is when you retrofit blocks to a tool, it's critical that you have proper alignment. And this, I know from years in the shop, you run a tool for a time and the leader pins and the leader alignment system may become worn. So right even before you begin to think about installing a set of blocks, and make sure that you get your alignment of your tool back in order, and so that you won't have misalignment in the block itself. Of course, you can damage them if they're not properly aligned, and also shut off the evacuation path.
Right. The and those keys are precision machine and such, and they allow again proper alignment. And if you follow close tolerances that we recommend on our for our blocks and such, and for information we have on our website, that you'll get proper alignment as well. So the next cause that we have here is pinch, clogged, or punctured vacuum hose, and this is rather a good thing to take a look at each time you're loading in a new tool. You just want to make sure that you do not have any kinks, that there's no obstructions and such. These hoses that some may need to be replaced. They do generally last a long time, but you want to inspect the equipment each time you put a new tool in. And then that leads to the next cause, the plugged filters. So with the Midland setup, we have two filters: a media filter and a knockdown filter. Excuse me. And depending on your tool, your application, your process, they may be cleaned perhaps once a week or maybe each shift. And there are screens in the media filter that can be replaced. And on the knockdown filter, we have a baffle design that take the filter apart, and you can clean off any debris that you might have on the baffles. We also have a valve that you can open to that you might have a little bit of liquid in there that you can drain. But you'll have to. We recommend that you monitor your process and determine when your maintenance will have to be done. Perhaps you can have a set of filters off to the side, and each shift replace the filters with the ones that you have in stock, and then take the old ones out and clean them up and get them ready for the next shift. So it's things that you'll need to look at with your preventive maintenance. And one more thing with the inadequate evacuation is whether you have low or no vacuum. And Larry, if you can kind of go over this one as well.
Sure. This isn't untypical, and we get a lot of questions from customers if they are having problems. Well, what can I do to measure the amount of vacuum I'm pouring? And there's different ways to do it. I like to do it at the pour hole, and if you do that, it's a simple matter, really, of plugging that pour hole so that it's obviously not leaking, and then installing a vacuum gauge in the device that you use. I've used rubber stoppers. I've used pieces of rubber wrapped around the shot sleeve to have the same ID OD on between the sleeve and the rubber membrane, and then clamp it on and put a hole in it. Pretty straightforward, and close the dime and activate the vacuum and read the gauge. and that'll show you right away if you've got a plug, and you've got some obstruction in the in the block, because that's what we're looking for in this particular instance, is a blockage somewhere in the system. It could be it can also be your filter plug. That's a possibility, but you get a reading then, and of course we suggest making sure that that you keep the blocks clean. We've had instances where die casters were saying they were getting buildup on their blocks. Well, this is the same as a die needs to be blown off, and release agent can be sprayed on the blocks themselves, and then a good blow off will help prevent the the adhesion of the particles, which are all part of this particular process, the particles from adhering to the teeth and possibly clogging up your vacuum system. And of course, as we mentioned before, you want to check the alignment between the blocks once you've determined that you don't have, you're not pulling a vacuum, or at least the level that you may want. As a general rule, this is just general. It doesn't mean that this is in every case, but we like to see vacuum levels between 13 and maybe 21, 22 inches of mercury. That should be sufficient. So we've had some that go higher than that, obviously, and these are usually done without seals. You can utilize what's called quote unquote high vac or high vacuum die casting, which essentially means that you've sealed or minimized the amount of leakage in the tool itself, and those normally require some type of a seal. There's good news and bad news and everything. We know that. I've never personally designed a die with a seal in it, and I've done this for a few years. If you get to that level that you're having problems, you've got other issues besides just the evacuation. It may be an improper design gate. It may be a process problem. It may be other things that are affecting your effectiveness or your capability of evacuating the cavity. So that's really it. And always keep in mind too that as these tools wear, and everyone that runs a casting machine and runs a tool knows, as the die wears, of course, that misalignment goes out. It can be, and you run into trouble with other components of the tool besides these trying to hold tolerances. But it's important to keep your tools in good shape, and alignment is critical.
Right. Good. Okay. Well, the next issue that we see is flash around the vent blocks, and the possible cause, first possible cause we have here is the gap between vent block and cavity or runner insert, and this again gets to this adjustment installment of the blocks, and Larry, if you want to go through that detail a little more. Yeah.
Assuring yourself that you've got the blocks preloaded. When you install blocks, they should be preloaded to the same height as the cavity insert. If you use, and we indicate here a runner insert, and what that denotes is a steel block, hard 813, same heat treated so it won't get peened over, same as a block. And we want to preload those all at the same height in the cavity, the same as you do a cavity insert, because you want to make sure that you don't have any leakage when you close the tool up. And that kind of segues into the next one. There is die holding open, fully contained within the runner, within the blocks in the runner. If you don't have that shut off, you're going to experience this, which is that gap. Again, these are kind of related. Those two are related real well. And to determine, again, to assure that you're spraying, as I mentioned, and then also that you're blowing those blocks off. If you don't remove the flash up there, you're gonna, and you paint it over, you know you drop it. Same thing happens on the insert, and or if the tool is not, I've seen dies, and we see them shots a lot of times with excessive flash in different areas of the tool. Obviously, that's an indication that the tool isn't square, may have gotten peened over. Something's occurred that is not allowing it to be clean. So it goes back to that.
Right. And that, like you mentioned before, Larry, with as the tool is being used over and over, that over time that it can wear out, and you have a misalignment. That it's so important to check all that. Especially each time you put in a new tool.
Right.
And then the third cause here is that the excessive metal velocity, and we kind of hit on this earlier, but what we see here at Midland is the runner layout. That again, the runner might have been designed where the metal is shooting into the chill block at a rate that's it's just too high velocity. And again, what we recommend is a minimum of 5 90-degree turns on your runner outlet runners to the vacuum block, and that's that we see more once that's changed. That has more effectiveness than perhaps some type of a coating or something on the block. Would you agree with that, Larry?
Yes, that's right. And this is one of the big ones that we see a lot of, and complaints that people have, and we've seen it, and I believe we've made custom blocks with inserts in the tooth area where there's erosion, there's wear on the block itself. Those are all indications. Die casting 101, go right back. That indicates that the velocity of the metal when it arrives at that block is too high. Okay, and so the runner design and actually the outlet design are critical in minimizing this. We also have seen excessive erosion actually in the vacuum runners themselves, to the point that the runners were sticking in the tool. So these are things you need to take into consideration. It could also be the design of the outlet itself in relationship to the area of the outlet at the casting. So what we want to do in these instances is we want to when we design a gate, we want to go from large areas to small areas so we get to the casting, which helps accelerate the metal. And you can use the geometry of a runner to actually help yourself. I've done this, and minimize the amount of resistance to the metal flow to the casting. Now, conversely, you want to decrease the velocity of the metal when you leave the casting. So you want to do the opposite. You want to go from a smaller to a larger when you leave the casting, and that will help decrease the velocity, hopefully, if designed properly.
Excellent. So the next cause or the next issue with evacuation that might be out there is the failure to achieve expected vacuum level beyond the solenoid valve. And one of the causes is a low vacuum level, and primary at the pump or the tank. And some of the things you want to do is ensure all drain valves are closed, ensure that there are no leaks at each of the junctions of your vacuum line, and of course the pump itself needs to be maintained. You want to check your oil level and the oil quality, and change them as needed. And there's also inlet filters and such that you either want to clean or replace. And in some cases, depending on how old the pump is, it may need an overhaul. There are overhaul kits that are available that you can basically replaces some seals and typically the filters as well. But you'll get everything all tight, so your pump is being used efficiently and can create the vacuum level that you need. And then also to verify that the pump and reservoir size is large enough for your application. And here at Midland, we also have offer a service where we can determine the pump size and the reservoir size based on the parameters that you have, depending on basically like the shot size that you're going to have, or the maximum shot size that you might have in the future, the number of machines, die-cast machines that you might hooked up to that to a single line, and then also the maximum shots you can have per hour, and we have a form that you can fill out, and we can determine the vacuum pump size and reservoir size for your application. And the next troubleshooting occurrence is metal fines in the vacuum holes, and this is where the very first thing is caused is no filtering, and so we certainly do suggest that you install a filter close to the vacuum block. And again, with our hookup kit from Midland, we have a knockdown filter and a media filter. And as we talked before, these filters do need cleaning. They can get clogged depending on your applications. Some environments may not see as much particles go through. Other environments may have a little bit more. So it kind of depends on your situation. And then again, high metal velocity can also cause metal fines in your vacuum holes. And this again goes back to the runner layout and putting in the 90-degree turns and such. And Larry, do you have anything else to add with the metal fines?
No, other than I experienced those early on. I think, well, almost all jobs I've seen have some fines in them. There's just almost no way in the world that you're going to completely eradicate the fines, and of course that's the reason for the filtering. You're going to experience it, but you can minimize that by keeping control of the metal velocity as it goes through the block, at least the amount of it.
Right. Okay. Next issue is the metal sticking to blocks, serrations, and erosion. And again, the possible cause, we hit it again right away, the excessive metal velocity. And again, we're still emphasizing a lot with the runner layout and putting the 90-degree turns in there. And that we recommend vent or vacuum gates opposed to overflows for attaching runners. And then also you have possible causes of damaged block. And of course you want to replace blocks if there are any pits, nicks, or broken teeth. And Larry, can you kind of talk a little bit about as far as cleaning up a block, if it's what signs where you may be able to clean it up, or other times where you're going to have to replace it?
Yeah, well, you'll know when you have to replace it, of course, when there's pieces missing from it or teeth are damaged. Of course, we always recommend you never use steel on them, and recommending that you use a wire brush of some sort to remove any buildup that you experience. If you solder, we mentioned solder down below. That problem can, when it does come up, the only means that you can use to remove solder, or the best means to completely remove it, is to polish. And in those instances, we do offer coatings. Now, it's important for people to remember that there are two different types of coatings. There's coatings that are surface coatings, and there are coatings that penetrate the steel. If you take even a wire brush in some cases with a surface coating, and certainly with a stone, if you go to work to remove solder buildup on that block, you're going to also remove the coating. So it's important to keep in mind that what you do to fix one problem can exacerbate another problem in that case. One thing, Bill, I'm going to jump back to real quick, and it was put in here intentionally, and that's the fact that trying to minimize the metal velocity, can help in a lot of these cases. And one way we've discovered that helps quite a bit, die casters generally will want to add runners for and create the vacuum runner system off of an overflow. We know, and physics tells you, that if you go from a large area to a small area, you're going to accelerate whatever the material is that you're flowing through those passages. And that occurs when you go into a large overflow and then come off that overflow with a small vacuum runner. We've seen dies that, as I mentioned before, that were eroded to the point that there were grooves in the runners so that the runners were sticking. Obviously an indication that high velocity of metal, was the culprit in that case. So we recommend using vacuum. We just define them as a gate, an outlet gate. Use that in the design opposed to using overflows. You have to use overflows, fine. But that's a recommendation that we've arrived at after experiencing problems. As far as the solder goes, utilizing cooling lines in the blocks to minimize that too. And then again, I mentioned spray. The reality is that spray is primarily used in most die casters as a means of assisting cooling of the cavity or cooling of an area specifically. And in this case, in the instance of, we're not worried about making a pretty looking vacuum serrated pattern, after we leave the casting. So in this instance, if you spray it properly and blow off, you're going to minimize that problem. So, and then I'll just continue here with the thin gap between the front teeth, replacing the vent blocks with a variable teeth pattern. You can elaborate a little bit on that, because we do have that capability, Bill.
Right, exactly. Yeah. So that it basically it kind of gives you creates a little bit thicker metal on the thicker distance between the serrated teeth on the blocks and the beginning of the block. Here at Midland, we develop a variable pattern, and again, that affects the front half of or the front third of the block. And what we have found is that when customers do have issues with the metal sticking, that sometimes the metal might be too thin, and so as you eject it, it might stick to the vent block. And with the variable block, that a lot of times that can help with just gives you that extra strength in the metal, extra thickness on the metal as you eject it, and it will come off the block. So again, it is something that we have available, and certainly something you can request if you order blocks from us. So on the next one, we have another issue is metal blowing through vacuum or vent block. And as we can see, the very top one is that excessive metal velocity, and and again, we still emphasize the proper outlet runner design. And as Larry said on the previous screen with the, that when you do a proper runner layout, that can a lot of times to solve all the issues that you're seeing. That unless you have a damaged block and such, well, that can create issues with metal sticking. But like we have here, the metal velocity, if a proper runner layout can certainly resolve some of your issues. And again, another cause for metal blowing through the vacuum vent block might be a damaged block. And again, you need to repair the blocks. But a lot of times when you have these types of cases, damage that the blocks do need to be replaced. Okay, well, that ends our the slides for our presentation. We do have a few questions that came up, and Steve is going to read those off. And if you have any questions during this time, you can still submit a question. We'll try to get it answered.
Well, the first question we have for you, Bill and Larry, here, and this is pretty generic here, pretty open-ended, but it just says, how do we avoid porosity?
Right, and that well, the proper evacuation with venting or vacuum, and what we take in consideration is the fill time and the area necessary to evacuate the gas has to be considered. And Larry, maybe you can emphasize that a little bit more.
Yeah, just one thing I'd like to point out, that you don't eliminate porosity. It's impossible physically. You can't. It is inherent in the die cast process. Okay, and of course we all know, if you've been in die casting any period of time, that there's two types of porosity: shrink, which we're not addressing in this issue, in this discussion, and or gas, and we are discussing gas. So that's the first thing to realize. There's no elimination of porosity. So as Bill mentioned, what we always look at is, how do we minimize the amount of porosity? Because no matter what you do when you make a casting, and it's been one of the causes in the past, one of the reasons for people not using die castings, because they were so susceptible to porosity. And I always say, if you have adequate evacuation, it's going to minimize the amount of porosity that you experience. If you've used adequate venting, either with the chill block, conventional vents are fine, except for the problem that they really don't have the area necessary to evacuate, because the space that you have usually to atmosphere is only from 5 to 6 thousandths. So times whatever the actual width of the evacuation path is. So using either some means of a chill block or a vacuum assistant is real beneficial in that instance. But and then the other thing to do, as I mentioned, is proper design of your gates and your runners into the cavity, and likewise the process parameters that you established on your machine. How you've determined how you're going to set that machine up and run it, and what that machine's capabilities are. That's critical too. If you have a machine that has lacks monitoring, some means or control, that can also affect it. It's a pretty broad, question. But when you look at the issue of porosity being the major issue with die casting, it needs to be addressed from, I call it, from the front end to the back end. And we're kind of going into the back end and utilizing the tools that are available to you when you design.
Excellent.
Perfect. So the next question that we have here for the two of you is what are the mechanics behind degassing?
The mechanics?
Okay.
Sure. The mechanics as I mentioned earlier in the presentation, the mechanics are that die castings outgas their entire life as a product. That's just the inherent nature. It's physics. Okay. So what we're addressed with is the amount of time that and the degree that outgassing occurs during the life of the part, and most of that occurs right away. And you can tell that a lot of times when you run a casting. I used to do it. You run a casting, you'd pull it out of the machine, didn't see a blister, and all of a sudden, I got a blister on the surface of the casting. Well, there's ways to eliminate that. It's like people say, well, vacuum or chill block venting is a crutch. Well, if you got a broken leg, sometimes you need a crutch, and most of the time you do. And it's the same way in this instance. But to alleviate that particular problem, there are, and if you contact us, we can give you some information on outgassing a casting after you've made it. If it blisters, right away you've got a serious issue. You're going to have a serious issue too if you have minor gases, or even if you've dispersed the gases throughout the casting. I've had some jobs that because we were powder coating, happens a lot in powder coating because of the higher temperatures used in curing the metal, setting. The paint, setting the paint, and temperatures used. Then wet paint is much liquid paint uses a lesser temperature. Plating, of course, you heat the casting up. And the secondary processes can be wheelabrating. If you wheelabrate a part, or you perform any operation on the surface of the part, can create that outgassing, or I call it what looks like the zits. If you look at them under a microscope, they look like a little volcano, and you can actually see the crack in the casting and the area that the outgassing has occurred. To rectify that problem after the fact, if you have adequate evacuation and minimize porosity, that may not be the case. But if you do and you expect it, you want to include in your process and your cost, okay? Because it costs money to put the casting in a furnace and evacuate and heat it up for a particular length of time to create this premature or accelerated outgassing, I'll call it. So if you contact Midland, I've got the times and temperatures and so forth for alloys and all that to help you with that.
Perfect. So you've already kind of answered in part this next question here, but how can you avoid the following defects? Lamination, poles, of course we talked about outgassing already, but then cold flow as well.
Well, each of those. Go ahead, Bill.
Well, I'm just that's another good question. Some of the stuff we had already talked about in previous webinars, but go ahead, Larry.
Yeah. Well, of course, lamination occurs because of the two fronts of metal coming into contact and not being, I'll call it homogeneous, but not being in a liquid state, but being prematurely solidified. And when they come in contact, they create laminations. That can happen, and I know a lot of times, again, that relates back to the cavity fill, and that relates back to atomization. Is the metal atomized as it enters the cavity? One of the things that people forget about is the fact that there's a minimum atomization speed that is required to fill a casting. We're talking die casting is a turbulent flow process. It is not a laminar flow process as gravity casting is, okay? Or even low pressure die casting. So you've got to know the parameters, and you've got to apply the proper calculations and setup of your machine to overcome something like laminations. laminating castings. I've had it occur on parts that we wheel abraded or blasted, sandblasted, because if you upset the surface of the casting and you heat it up, you change the temperature, the part is going to outgas. You could probably minimize that to a certain degree. What we found is it was the amount of time it took to perform it. It may be the size of shot that you use, but again, if you fill the cavity in the minimum amount of time in the proper way, like pre-fill. A lot of people will talk about pre-filling the cavity using a slow shot. Well, if you have to do that, there's some other issues with your process. It could be in your design of your gating system itself, and it could also be the process that you're running, maybe location of gates. Could be a lot of issues. It's a complicated process. But if you do the basics and the ABC, so to speak, you can pretty much minimize that. Did you also say hole? You mentioned holes.
I did. I'm gonna just quick mention. We've got about 4 minutes left of the webinar here, and a couple more questions we want to get to.
Right.
So keep that in mind here.
Go ahead. We can continue with the question.
Yeah, and we can. If somebody has needs more in-depth answer, you certainly can call us, and we can answer your question after the webinar. But this question, I think.
Yeah. Why don't we jump on here to how do you justify the economic cost of vacuum die casting compared to conventional die casting?
Right. So, well, the rejection of the parts that rate is much less using vacuum assist than conventional evacuation. We've seen that a lot with a number of customers. Especially if you have parts that maybe thin wall parts or perhaps critical parts that are used like a structural or safety components in the automotive industry, and having your rate of rejection drops down, so that kind of justifies the higher cost of the process for a vacuum assist. I think Larry.
The other one. Go ahead.
Oh, I'm sorry. Go ahead.
Yeah, I was just going to say that very, very quickly. The amount of metal that you lose, if you do some calculations on the amount of when I say that, I'm talking about metal thrown away in the form of flash and so forth. If you just took that cost on a machine, if you're depending on, again, the mix of parts you're running and the criticalness of the part, you can find out real quick that you can save money by producing better castings. I always talk about yield. Yield is what you want. It doesn't really matter. People have told me, well, I'm going to add more metal to my casting, my shot, so I'm going to have to remelt or and so forth. Well, yeah, you're right. But if you're not selling the casting, it really doesn't matter how much metal you save, does it? I had one die caster once told me that he didn't need to put overflows and vents in the casting. Unfortunately, he was having to he had to put a line in to impregnate his casting. So all these things are trade-offs. Better go on with the next question.
Okay.
Yeah. So next question here we have is, how does the evacuation area compare between high pressure die casting versus permanent mold?
So how does evacuation compare between high pressure die casting versus permanent mold? Sure.
Quickly, for those that don't know permanent mold, and they probably do, permanent mold is a gravity cast process that's laminar flow. Subsequently, because when we do calculations on high pressure die casting, we base our calculations on the cavity fill time and the volume that we're replacing. That same application would certainly apply with with permanent mold in that instance. The size of overflows, however, and you get into a whole different bag when you go to gravity forecasting, and so that you could certainly use a vacuum assist on permanent mold, which would enhance the castings because they have problems with that laminar flow. I don't want to get into all the physics and so forth between the two, and we can explain the processes, but it would be applicable to use vacuum in permanent mold the same way as die cast. However, calculations and so forth would be different.
Perfect. So, last question here. What type of lubrication system is used with vacuum assist die casting?
None that I know of. I mean, the only other than the lubrication, you possibly, depending on what kind of a vacuum pump you're running, there really isn't any lubrication. The only lubrication I'd say would be the spray and the release agent that you'd want to apply to the either a chill block or a vacuum block in these instances to make sure that you're getting an adequate blow off of the flies.
Right. Yeah, so you're not really using any type of different lubrication compared to conventional evacuation or using the vacuum or vented chill blocks. It's basically the same.
Yeah, there isn't any.
Right.
You know what? I did miss one more. I know we're running late on time here, but this one I think has been pretty much answered already, so it should be fairly quick. Then we can let everyone go here. But how do you the initial parameters? How is the relationship between the equipment parameters and the defects on a casting? I'm assuming this is relating to vacuum die casting again.
Right. Well, you certainly want to make sure you have the proper size machine and such for the part that you're the size of the part that you're creating, and of course the proper speed and such, your slow shot, your fast shot, your cavity fill time, all things that you need to consider. The pressures on the accumulator and such. And Larry, if you can emphasize that a little bit more too.
Yeah, just do what you normally do. I mean, do the calculations. If you calculate a gate, if you calculate and you design your gating system, this should all be incorporated at the same time. You do that by a series of calculations. Run PQ squared. Determine how fast your metal is at the gate, what your cavity fill time is, what your volumes are. It's all part of the calculations required in designing a good tool that's going to function for you. I guess that's about as much as I can say. And then establishing and make sure that your process is monitored. I can't emphasize that enough. So many die casters don't have adequate monitoring, let alone controls. Control, of course, is better than monitoring. I always say it's better to control things than it is to find out you made a bad one after the fact and have it recorded. That's what they used to do when just monitors were around and no controls. It was like collecting information after you made the problem. Why wouldn't I want to control the problem before I make the casting? Never quite equated with me, but that's what a lot of people wanted to know, how many bad castings I made and why did I make them. Well, if I don't make them, then I don't have any. You don't have to worry about that. So that's my thought.
Okay, good. Steve, do I have any more questions?
Nope. You know what? That looks like we've answered all of them at this time. I want to just thank everyone who joined in on this webinar series here. We really appreciate everyone being active listeners, and we look forward to the next webinar series we can meet with you on. Thanks, and everybody have a great day here.
All right. Thanks, everyone.
Thank you.